have level 5, yeah, up to 4 only. And this one is using internationally. Okay, no matter where you go, okay, when let's say you are working on this motherboard, to assembly the motherboard. So motherboard assembly process level is level 2 lah. So when you say you're working in level 2 interconnection packaging, so they will know you are at motherboard assembly process. Okay. Okay, so let's see what is level 0. So level 0 is this what is this? This is on the chip level. Means what? They design the circuit. These are all this design. Okay, wafer fabrication. This one is what we call level 0. Okay, logic gate, transistor gate to gate interconnection on a monolithic silicon chips. Okay, so this one is all the design on this chip. This is level 0. Okay, level 1. Okay, so when we have this one, all the chips, we need to protect it, right? So we need a carrier. Okay, what we call it as a chip carrier. Okay, chip carrier. Okay, chip carrier. Sometimes they call it as substrate also. Okay, sometimes they call it as substrate. Here. Sometimes they call it as substrate. Okay, sometimes they call it as chip carrier. Yeah, so there are many terms. So I try to introduce you as many as possible lah. Okay, so these silicon chips, they need to put on this chip carrier. Why? Need to protect it because this one very fragile, easily to break. So you need something to protect it. Then attach on the chip carrier. So the chip attached on the chip carrier is what we call level 1. Level 1 packaging process. Who want to enter? Who is this? Who? Who just entered just now? Who is Muhammad Jabil? Who is Muhammad Jabil? Oh, drop already. How come we have foreign visitor one? Never mind. Okay. Okay, level 1. Okay, so the chip level interconnect that join the chip to the lead frame. Okay, some you attach on the chip carrier already. So sometimes they use the lead frame also. This one don't worry. Later we will see in detail. So basically now you just have an image. What is it? Okay. So as I say, the level 2 is on this PWB lah. Okay. Sometimes they call it as PWB, printed wiring board, but sometimes they call it as PCB also, printed circuit board, and sometimes they call it as motherboard also. Okay, so they are all the same thing lah. Okay, all the same thing. So this one, after the silicon put on the chip carrier, okay, so you need to have interconnect with all the neighbors, right? So you need a bigger board. This chip carrier actually is a small board, very small board. Okay, this one is to protect this silicon chip. Okay, when silicon chip attach on this chip carrier, then it will attach on this bigger board. The green color that you saw, the one that has a transistor and everything inside. Okay, whatever you have. So they can communicate with neighborhood. Okay, so this is that bigger board lah. So assembly, this one is a continuous process. You see, it's a continuous process. So from here come to here, then assembly, okay, PCB assembly or PWB assembly. Okay, so what's the purpose? All are providing interconnection. Okay, so this is what we call second level interconnection process. It's on the motherboard. Okay, printed conductor path connect the device lead to of components to PWB. Okay, all these components they will assembly not only this silicon chip but other transistor diode all they will assembly on this motherboard. Okay, that process is level 2 lah. Okay, is level 2. So ensure that you have electrical interconnection. Okay, then after that, after level 2, what they will do? Okay, so they will connect between two or more sub-assembly. Okay, if you have different motherboard, then you want to assembly together. This one is level 3 lah, to make it into a complete system. Okay, so normally they use a frame or a rack, okay, to put them together. Okay, this is level 3. Level 4 is when you have this complete system, you need to connect with other. For example, this one you have, for example, your workstation, right? Okay, so you need to connect to computer, connect to printer to make it into a full system. This is level 4 lah. Okay, this is level 4. So in short, I show you the picture here. Okay, so level 0 basically is the chip level lah, transistor to transistor. Okay, so this one we need protection, then we need a chip carrier. So chip to package. Okay, chip attached on the chip carrier to form a package. This is level 1. Okay, so this package need to communicate with other component, right? How they communicate? So they need to sit on one bigger board lah. Okay, package to board. This is level 2. Okay, PWB or PCB or motherboard lah. Okay, so after that, if you have different function of motherboard they want to put together, then they will put inside a rack to form a complete system. Okay, board to rack. Level 3. So this rack you want to connect to other system, for example, printer, computer, and etc. So this to make it fully function. So this is level 4. So in factory they divided by this one, level 0, level 1, level 2. Most of our country we start with level 1 and level 2 and 3 and 4 lah. Yeah. Okay, so this is a 1 So in short, 0 level, IC chip level. First level interconnection, this one, the chip on the chip carrier. Okay, the chip on the chip carrier. Okay, of course, the chip on the chip carrier also, it cannot be open. So later we will learn. We will, like this one is what we call encapsulation. Okay, encapsulate means mold. We molded it with a layer of plastic lah. Okay, to protect this, especially when you have wire, you need to protect it. If not, you exposed to air environment, this wire when handling also, it will cause damage. Okay, it will cause damage. So second level basically assembly all the component on a motherboard lah. Okay, on a PCBs. Okay, so many different function PCBs you put together. Okay, connect to a motherboard. Okay, so this is the third level. So the fourth level will be a complete system. Okay, it will be a complete system. Okay, so I have shown you like this one is a flowchart. This one is a picture and this is also a picture. Okay, this one simplify one. Okay, this one is explained in detail one. So summary of IC assembly, IC packaging. This one's level 0. level 1, level 2, level 3, and level 4. Okay, so IC packaging normally, sorry, IC packaging normally involved in here lah, the front line one. Okay, the front line. Okay, this is what we always say IC as packaging, right? IC assembly is this one lah. Okay, but PWB assembly is this one. When next time you go for interview, wafer level assembly this one lah. But this one seldom do in Malaysia. So mostly IC assembly or the board assembly. Okay. Okay. So this one is level 0. It's not your scope. This one is like micro E&E. Okay. Electrical and electronic, microelectronics. They will learn about this one. Okay. So our job mostly involved in here and here lah. Okay. This one is very simple. Just assembly into a system. Okay. Very simple. So mostly in here lah, IC assembly and motherboard assembly. Okay. So I will focus on this first level. Okay. This one you got a lot of things to be learned. Okay. This one after you learn this one, if you have time, if you want, I try to explain on this one. Okay. More complicated this one. Okay. So but your syllabus is here. IC assembly is already very complicated. Already enough. Okay. So first level interconnection. So this is what we call first level interconnection. You learn all about this one. Okay. Okay. If you still remember first level interconnection, what's the function? Is to attach a chip on a chip carrier. Correct or not? Okay. What is the purpose? What is the purpose? We want to attach this chip on a chip carrier to protect the chip lah. Okay. For easier handling lah. For easier to do handling from one station to another station. Okay. While doing this one, you attach your chip on the chip carrier. You must make sure that you have electrical signal can go in and out. Okay, from a single transistor or IC. Okay, this IC, if you attach on a chip carrier or on the substrate, make sure you will have electrical signal. Okay, then the power can be on. Okay, electrical signal that can transport, okay, or transfer from into or out from the chip, into the chip or out from the chip. Okay, so in other words, the interconnection required between bonding pads of the IC and the pin on the package. What is this? Okay, I try to show you a little bit. Okay, so you see this one is the silicon chip, right? So when you want to attach, you need to solid what we call it as a saw die saw. Okay, you need to solid it. Okay, you need to solid it into single piece. Then they will pick it using a vacuum, pick this one and attach on a chip carrier. If this one is a chip carrier, so if they will pick it and let it form bonding on this chip carrier. Okay, so right now this one is silicon chip. Okay, but the chip carrier right now, we are using polymer already. Okay, we are using polymer. Plastic lah. Okay, so you know, right? Plastic is conductor or insulator. Most plastic.
Insulator.
Insulator, right? Insulator means can can conduct electric or not?
Cannot.
Cannot, right? Okay, so you see, if we have this is silicon chips, okay, and we have a motherboard, okay. Okay, of course you need interconnection, right? Means you need to have a route to transfer all the signal here, go through here, right? Then this one will assembly on a bigger motherboard, correct or not? Okay, so all these thing, this three from this chip, okay, so let's say this is the chip, and this is the chip, chip carrier, this is a chip carrier, and this is a PWB, PWB, all these things, they will attach together, but you make sure the electric signal can go through here and come to here. Can you imagine? I can go through here and come to here. So they will attach together lah. Okay. So have you ever wondered how? Because this one is plastic, you know. This thing and this thing is plastic. Okay. How does the electrical signal can transfer? So actually inside this substrate, okay, they have a design. Wait, I see whether I have the picture on this one. Actually, if this is the substrate, okay, actually they have wire, what we call it as copper pad, no, copper layer, copper layer. Copper is metal, right? Metal can conduct electric. So they put layer by layer. So they design there's a route. So you have a path, what we call it a path, like a route, to transfer the electrical signal. From here, go through this substrate. The green color one is plastic, Green color is insulator. So they put the yellow color one. Yellow color one is the copper trace, okay, or copper layer. So it can go through, so that the signal can go through. If not, if it doesn't have all this layer, so the signal cannot go through because the green color thing is insulator. Okay, so you see, okay, this one is using many small ball, right? Many small ball is what we call it as bump or solder ball. Okay, so this green color is a plastic. Plastic and metal can form good bonding or not? What do you think? Can form good bonding or not? Metal and polymer. Can or cannot?
Cannot.
Cannot, Okay, if cannot, how are they going to be attached together? So this one from top view is I think I open the new slide. From top view is like this, right? Okay. From top view is like this, right? Okay, top view, Okay. Very ugly, Can, accept it, Okay. So how to attach? This whole thing this whole thing, right, is plastic. How to attach? So that's why we have this one. Wow, what is this? Remember, later you will see many times this one, bonding pads. Bonding pads means the pads whereby can form bonding one. So you will have they design there such as all these are what we call pads. These pads is made from copper, copper surface, okay, or platinum. Many type of surface, but it must be electrical conductor. So it's normally it's metal lah. Okay, many can make from many type of metal. So that later all this ball it can sit on top of here and form bonding. You understand or not? Because this one are plastic, okay? So they were actually it's round shape lah, not this ugly. So imagine it is round shape, okay? So many pads all every single pads will have one ball sitting on it and form bonding. And this one is only the top layer. So you see at the center, actually you have many layer. Okay, just now I shown you what is just on top layer only. Okay, so this one is top view, right? So side view how? Side view, if this one is a substrate, side view they will do lah. Here is copper. Here is copper. And here is copper. The whole thing is a copper. Okay, we will do something like this. Okay, so this one is plastic. Okay, then they will have many layers. They form a puff, many layer. Okay, very ugly. So we see this one. Many layer. So the signal can go through from this chip, go through this plastic substrate. Okay, and this ball is also solder, right? Solder is metal, can conduct electric. Then come to PCB. PCB also is another plastic like this. Inside here also have many design, copper trace. Okay, so that your signal can come here and go to the neighbor one. Maybe you want to connect to transistor or diode. Okay, all the neighborhood here. Okay, so the signal can go through. This is how they design. Okay, how they design. Okay, why they want to use plastic? Why they want to use plastic? Because it's light. Because it's light. Before they use plastic, actually they use ceramic. Ceramic, of course, is very, very good, very thermostable, but it is very heavy. Okay, so that the solder will not form joint on here, on the plastic things. The solder will not form joint on these plastic things, only will form joint on here. Okay, on here. So they will have pattern. Okay, they will have pattern. Later I show you how. Okay, so all outside here will not form joint. So solder ball after refold it will melt, right? So they will only sit on here. They will not flow out from here. So that they can have something very nice bonding. Okay, so this is the bonding pads. So this is the new term. Okay, so sometimes they use the pads. Okay, when they use the pads means they use solder ball or wire. Okay, because wire also can form bonding on the pads. This wire. Okay, when you see they use the pin means just plug in only. Later I show you. Sometimes they will use only the pin. Okay, they just plug in only. Okay, this one understand, this one can understand or not? Can follow? Can follow?
Yes.
Yes, Yeah, take away here. Okay, so only this first level, actually we have three type of technology. Only three. One is using wire, called wire bonding. One is using flip chip. Flip chip means flip over the chip. Okay, we will see this one. We will learn this one by one. Okay, so one is tap automated bonding. Okay, so you see bonding is to bond the chip is IC on a chip carrier. So bonding, you see bonding. What's the purpose of all this bonding? To provide electrical signal that go into or out from the IC, and in short, to provide interconnection. This one can understand or not? Can understand or not?
Yes.
Okay. So I now I introduce to you. First, we go to wire bonding. Okay. Wire bonding means, of course, using wire lah. Okay, using wire. Very simple, right? Okay. So which one is the chip? This one, the gold color one, this is what? Adhesive lah. Adhesive. Because you want to stick the chip on the chip carrier, right? This is green color is the chip carrier lah. So how to stick on it? Use, have you heard about um, electrical conductive adhesive? This is the one. This is the one now to stick lah. Okay. So wire, okay, this one is side view. This one is side view. Okay. Just now that I shown to you, this one is solder ball lah. Actually, this one is using solder ball technology. Solder ball technology is flip chip lah. Okay, this is using solder ball.